The next thing we're going to cover is wrap feature, which is also introduction to equations. So I'm going to start this by creating a cylinder in the top plane. That cylinder is going to be 10 in diameter. And we'll draw the circle, dimension it, 10 in diameter. I'm going to create also some center lines that go from quadrant to quadrant. And the reason for the center lines is just to help me with some work planes later. So we'll create that. Then if we say OK to that and extrude it, we're going to extrude this thing 6 inches. So it goes up 6. That's our cylinder. I need to create the sketch that is going to be wrapped around this cylinder. In order to create that sketch, we have to have a reference plane. So I'm going to show this sketch that I drew because it has that construction line on it, and then I'm going to create a reference plane on the surface through that point, and that'll be our plane where we're going to create the sketch. So the sketch, as we create the sketch that's going to be for the wrap, is created on that plane. We can go ahead and look right at it and then generate that sketch. I'm just going to create the sketch to start with, and then we can define it. And I'm going to define that sketch with ordinate dimensioning. Be careful with the constraints that are being applied. Make sure that they're just horizontal and vertical and not, oops, I got a parallel. Not a big deal, but we can go ahead and add in the rest of our lines, and then go ahead and look at what was created with the relationships. I'm going to get rid of the relationships that are parallel because of the way I'm going to dimension it. So these are all going to get deleted. I do want to have all the top lines going across be collinear, and all the bottom lines going across be collinear, and in fact the top edge and the top edge of my sketch being collinear, and maybe even the top edge being horizontal. I'm doing a lot of my relationships first and then can throw on the dimensions. So we can put on our smart dimension of this top edge is at 35, and then I'm going to use ordinate dimensioning with the top being 0, and do ordinate dimensioning to decide or to put in how big it is. So that should be 2.5, and this one here should be 5. Then I can continue with my ordinate dimensioning, going from the left side down. Whoops, cancel that. Hold on. You can't have anything selected when you do it. So again, ordinate dimensioning, this one on this side, and then each one of these points as we move across. That's why I took off the parallels, because I'm dimensioning to each one of the corners. Right? And then we can go ahead and change those. The first one should be 5. The next one should be 6. The next one's 8. The next one's 9. Then 13, 14, 21, 22, and it's starting to get a little out of shape. And then 26, 27, and 29, and the last one should be 30. Okay, that should do it. And then the last thing I want to do is put in a center line that goes from the origin straight up, and then take the midpoint of this line and the endpoint of my center line and make them coincident to center it going that direction. Okay, the next thing we do is create an equation. This dimension up here, that's at the very top, is D1. It says over here D1 at sketch 2. And so what I want to do is make that equal to pi times the diameter of the cylinder. So if I go back to the sketch of the cylinder and show that, if we go back in and to the sketch of the cylinder, it has 10, and that dimension is D1 at sketch 1. So it's D1 at sketch 1 and D1 at sketch 2. So if I go back into Tools, and down in my Tools you'll find equations. In the equation box, I'm going to go to my dimension that I want to add an equation to and select it. It'll fill in. Is equal to what? Well, it's equal to the, we'll remove that. I selected that sketch, so it said sketch 1, but it's going to be equal to the dimension D1 at sketch 1, but it's going to be pi times D1 at sketch 1, and then evaluate that equation. So you saw that I was able to pick the dimension right from the sketch in the browser. So select the sketch in the browser, pick the dimension, and it fills in the equation. D1 at sketch 2 is equal to pi times the D1 at sketch 1. It should be 31.42 because, well, the diameter was 10 and pi is 0.3142. When you say OK, now this sketch will wrap around, and when you look at that sketch, it now has an E next to it, or equation symbol next to it, because it's got an equation that's actually equal to pi times the diameter of the cylinder. That's how we use the equation dialog box. Now that I have my sketch, we can go back here and wrap it. Going to wrap. We're going to wrap this sketch around this face. We're going to deboss it, and the thickness of the deboss is 0.5. And after you've debossed it, we can turn off that sketch and we can mirror it. When you mirror it, though, we have the face we want to mirror it across, and then not just the features, but we'll mirror the bodies. We'll mirror the whole body. Have to mirror the whole body down because you have multiple features that we want to mirror. And then you can turn off the plane, hit the glasses, and turn the plane off. But it wraps perfectly around because we have that equation in our sketch for our wrap, which can be found from Tools, Equations, and we said that the length of the wrap sketch is equal to pi times the diameter of the original cylinder.